Okay, good evening. Am I audible? সবাই কি শুনতে পাচ্ছিস?
Yes, sir.
Yes, sir.
Okay, thank you. So today we want to discuss about this particular chapter. This is analytical chemistry. So analytical chemistry mainly based on the analysis. It is based on analysis. Analysis of which? Analysis of metal cations like aluminium, like magnesium, like zinc, etc. And also the analysis of anions. Mostly here we discuss about the analysis of metal cations. Not exactly the anions, but we discuss about the analysis of metal cation. So let's start this particular chapter. This is analytical chemistry. First of all, there are two types of analysis. What is analysis? Analysis means the determination of chemical components. Determination of chemical components in a given sample. Suppose in a test tube, suppose you can consider in this way that you are given a test tube. Okay. Now this test tube contains a white powder. Now this white powder, maybe that white powder may be calcium carbonate, or maybe zinc chloride, or maybe sodium sulfate. Whatever might be, you have to identify this white powder. What is the composition of this powder? Or even powder may contain more than one salt, like it contains sodium chloride and potassium bromide. So initially analysis means you have to identify a unknown chemical components which are present in a given sample. Now see the definition. Chemical components. These are chemical components like sodium chloride, potassium bromide, or even calcium carbonate. Single component may present. There may be presence of multiple components also. So determination of chemical components in a given sample. You should be given a sample. That sample having sample number like S1 is a sample, and that sample contains a white powder. Now we have to identify what is the components of this white powder. So the method that should be applied, method that should be used to determination of the composition of this white powder is actually known as analysis. Now analysis, generally there are two types of analysis. First of all, already we have discussed such a method that is generally known as qualitative analysis. qualitative analysis means when you are given a sample, that sample contains some components like X, like Y, like Z. That component should be identified through some different analytical technique. That type of analysis is known as qualitative analysis. Qualitative analysis means where you are given an unknown sample and you have to identify the chemical components of the unknown sample. Like already we have mentioned that white powder, this type of analysis is known as qualitative analysis. Now, there are another type of analysis. Suppose you are given a solution of a sample. Here is the solution of a sample. This is solution. Okay. Now, this solution contains a mixture of two salts like copper sulfate, and also sodium sulfate. It contains copper sulfate and sodium sulfate. Now, you have to determine, suppose this volume of the solution is 100 ml. Okay. So, it is clearly stated that this solution contains copper sulfate and sodium sulfate. So, here no need to determine what is the nature of the salts present in the solution. That is already known to you. That is, its solution contains copper sulfate and sodium sulfate. Now you have to determine what is the amount of copper sulfate or amount of sodium sulfate present in the solution. So when you determine the amount of a particular salt in a mixture or maybe single salt present in a solution, that type of analysis is known as quantitative analysis. So what is the basic difference between the qualitative and the quantitative analysis? In case of qualitative analysis, the salts are unknown to you and you have to determine the chemical component that is the salts in the particular sample. Now in the second case, that is the qualitative analysis, where a solution or a mixture of salts are given in a solution. Now you have to determine what is the amount of salt, known salt. That salt is not unknown to you. That salt may be copper sulfate or maybe zinc sulfate or maybe whatever might be. Now salts are known to you, but their amounts are unknown to you. So you have to determine what is the amount of copper sulfate or even sodium sulfate or zinc sulfate that is present in a particular amount of solution. So this is known as quantitative analysis. In our chapter, we generally discuss about the qualitative analysis, not the quantitative analysis. In higher class, you should deal with this particular part, that is the quantitative analysis. But in the present context, we should discuss only about the qualitative analysis. Okay, so we should continue with the qualitative analysis. Now, qualitative analysis. So, qualitative analysis means which involves the identification of the unknown substance. You have to identify the unknown substance. Now, in most of the cases, unknown substance, in our case, unknown substance is actually a salt. That salt may be something like this: sodium nitrate or aluminium chloride, etc. So each and every salt contains two parts. One part is the positive part and another one is negative part. The positive part is known as cation part, and the negative part is known as anion part. Now, in other words, you can say that cationic part is known as basic radical. Cationic part is known as basic radical, and the anionic part is known as acid radical. Acid radical. So a salt contains two parts. One part is known as basic radical and another part is known as acid radical. You have to identify what is the basic radical present in the salt and what is the acid radical present in the salt. That is actually known as qualitative analysis. Now the point is why the cationic part is known as basic radical or anionic part is known as acid radical. Now take an example like sodium nitrate, how this particular salt is formed. Sodium nitrate is formed by the reaction between sodium hydroxide and HNO3, nitric acid. So when sodium hydroxide reacts with nitric acid, they react with each other with the formation of sodium nitrate and water. This is simply acid base type reaction, neutralization reaction. Already we know that type of reaction where the acids and bases react with the formation of salt and water, and this is the salt. Now if you analyze this salt, then you see that its positive part, that is the sodium plus, this part coming from base, coming from this base, that is sodium hydroxide. Where from the sodium comes? That is from sodium hydroxide. And the nitrate part, this is the nitrate part, NO3 minus. This nitrate part coming from nitric acid. So that's why nitric acid is a acid. So that's why in sodium nitrate, sodium part is coming from base and the nitrate part is coming from acid. And that's why each and every salt contains a basic radical part and the acid radical part. So you have to identify, if you want to identify a particular salt, then you have to identify separately the acidic part of the salt and also the basic part of the salt. In this chapter, we generally determine the basic radical part of any salt, not the acid radical part, that is the anionic part. We here discuss about how to determine the basic radical part or the cationic part of a sample. So first of all, you see what is analysis. Second thing, how many types of analysis are there? That is qualitative and quantitative analysis. Out in case of qualitative analysis, what we have to analyze? We have to analyze the cationic portion and the anionic portion, that is the acid radical part and the basic radical part. But here we only discuss about the basic radical part, that is the metal cationic part, which we have to determine through qualitative analysis. Now, qualitative analysis is carried out with the help of certain reagents. Now what is reagent? Reagent means suppose you are given a sample like copper sulfate. Now you add some water to copper sulfate, and the formation of aqueous solution of copper sulfate. Now this is actually known as sample solution. Here in this sample you have to determine the copper part and the sulfate part. Now this is quite easy thing, that the sample is the salt that is given for analysis. Now taking this sample in a test tube, here you take some amount of copper sulfate solution or the sample solution, not copper sulfate, do not write in this way, write sample solution, because you have to determine it contains copper or sulfate or etc. So this is sample, and externally you add some, suppose you add some sodium hydroxide. Initially you add some sodium hydroxide. So sodium hydroxide should be termed as reagent. Reagent. Reagent means reagent is a substance that reacts with another substance. This another substance is sample. So in order to determine the sample, you have to add some of the chemicals externally, some of the substances externally, and that substances are known as reagent. So what is reagent? Reagent is nothing but such a chemical. By using those chemicals, we can determine what is the nature of the salt, or what is the acid radical or basic radical that is present in a given sample. So reagent is most important part of this analysis, because without using reagent you can't determine what is the nature of the salt that is given to you for the determination, for the qualitative determination of that particular salt. Without using reagent, how you should determine either which basic radical or which acid radical it contains? That's why the reagent is the most important part of this analysis. So that's why we mentioned that what is reagent? Reagent is such a substance that reacts with the sample and gives some observable change, gives some change that can be observed externally and confirm the nature of the salt or the acidic and basic part of the salt. Now we want to discuss initial observation. What do you mean by initial observation? Now let me clear one thing, that is you are given some salt. After taking that salt, you are given a particular salt in a test tube or in a sample tube. This type of sample tube, this is known as sample tube. This sample tube contains some salt. You have no idea about this salt. Teacher or sir do not give you any indication about this salt. You have to determine what is this particular salt. You have to determine. Now initial observation means only by seeing this salt, how you should think what should expected be the nature of the salt. Just by seeing. Now let me clear that if you have some conception that copper salts are generally blue or green in color, or you can say that iron salts, ferrous or ferric salts, generally they are yellow or brown in color. So when you get a sample, just see its color. Now color gives some idea about the nature of the salt, but this idea is not the confirmatory test. This is not the confirmatory test. This is simply an idea by which you can think about the salt or about the nature of the salt. But again I mention that the color of the salt is not the confirmation of that particular salt. There are so many other salts, they have color like copper, or even here we mentioned that copper salts are green, and so many chromium salts, they are also green. Ferrous salt, ferric salts, they are yellow brown. So many lead salts, they are also yellowish and brown. So color do not give a confirmation of the salt, but color can give you some idea about the salt. This is important. That's why initially we should take some conception about which type of salts are colored and which type of salts are colorless. Now here you see that salts of some representative elements. Representative elements mean mostly the second and the third period elements. and their salts are generally colorless. The representative element, salts of the representative element, is like you should say that sodium salts or aluminium salts or magnesium salts. They are generally, they do not have any color. Sodium salt, potassium salt, magnesium salt, calcium salts, aluminium salts, etc. Their salts are generally colorless. So, if you see your salt having without any color, then you should confirm that that salt may not contain. I I use this particular term, may not contain copper or ferrous or ferric or lead or chromium. Their salts are generally colored salts. So most of the representative elements are generally colorless. The salts of transition elements are generally colored. Salts of transition element. Can you say, can you give an example of transition element? Anyone?
Iron,
Exactly. Very good. Iron or
Copper,
chromium or even
copper,
copper. Yes. So iron, chromium, manganese, cobalt, nickel, copper, these type of elements are generally known as transition elements, and their salts are generally colored. Generally colored. You can confirm that all the salts of this type of compounds must be colored. They are generally colored. There are some exceptions over there, but generally the transition elements are generally they are colored, like copper, salts of copper, like salts of ferrous or ferric or chromium or manganese or cobalt or nickel, etc. These are transition elements, and their salts are generally colored, and also in solution they also impart some sort of colors. Now we list we follow a particular list where the different colors of the salts, in order to identify this color of the salts, they can help for the identification during the qualitative analysis. Now the color, already we have mentioned that color give you some idea about the salts, about the nature of the salts, but not the conformation. So different colors of the different salts can help you for the for this type of analysis. So here we mention some of the salts. Some of the salts, those salts are generally colorless, like ammonium salts, like ammonium chloride, ammonium sulfate, etc. All the ammonium salts, they are generally colorless. Also sodium salts, all the sodium salts, they are colorless. Potassium salts also colorless. Calcium, magnesium, aluminium, they their salts are generally colorless. Lead, some of the lead salts are colored, but most of the lead salts are generally colorless, and all the zinc salts are definitely colorless. So these are some ions, some cations. They their salts have no color, both in solid form or in solution. Again, here you see that some of the colored salts, that is like salts of cupric, like cupric nitrate or cupric sulfate, they are blue, or salts of ferrous, generally they are light green. Salts of ferric, they are yellowish brown. Like nickel, deep green. Chromium, also green. Manganese or manganic, they are pink or purple in color. So there are some cations are present. They are colored in nature. So you don't get any confirmation, because here you see that ferrous ion, those are green, and also here you see nickel ions, they are green, and the chromium ion, they are also green. So The green color should not confirm that presence of ferrous ion or nickel 2 plus ion or chromium plus. You have to prove them chemically by using some reagent. So color only gives you some indication about the metal ion, but do not give you the confirmation of the presence of that particular metal ion. Okay, next we should discuss the anions which are colorless. The anions which are colorless, that is mostly the chloride salts, they are colorless. Mostly sulfate salts, they are colorless. Carbonate salts, they are generally colorless. Also bicarbonate salt. Sulfide salt, they are not colorless. Some of the salts are colorless, but mostly sulfide salts also some color, like silver sulfide, like Ag2S. This is black in color. So there are some exceptions over there, but they are generally colorless. Bromide salts, they are also colorless. Acetate, they are also colorless. But the some of the anions like permanganate, this is very common, potassium permanganate, which is purple in color, or even permanganate, or even dichromate, which is orange in color. Now let me clear one thing, that cationic part is colored, anionic part is colorless. How you should uh, explain this particular fact? Like we take an example like this. We take an example that ammonium. Previously we have considered that this is colorless. Okay, this is colorless. Also we considered that chloride, it is colorless. Now ammonium chloride, so ammonium chloride will also be colorless. But just take an example, ammonium, it is colorless, but dichromate, it is orange in color. So what about ammonium dichromate? So when you see ammonium dichromate, its positive part is colorless, but the negative part, the dichromate part, is orange in color, Cr2O7. So ammonium dichromate should impart a color of orange. So when you consider the color of the particular salt, then you have to consider both the positive part and the negative part. If any of the part having color, then that salt must be colored one. But if one particular part is not colored and another part is also without any color, then that particular salt will be colorless. So this is one of the important points, that is potassium salts. All the potassium salts like potassium chloride, like potassium bromide, like potassium sulfate, like potassium nitrate, all those are colorless. But when potassium permanganate, when you write potassium permanganate, then though it is the salt of potassium, but due to the fact that permanganate ion, it is purple in color, so potassium permanganate is purple in color. So during the consideration of the color of the salts, you have to consider both the cationic and the anionic part, and if any one of them uh, impart the color, then the salt overall having some color. So the analysis of color should be done in this way, otherwise that may give some wrong information about the particular salt. That's why we mentioned some of the color of the salt. And also we mentioned that there are some exceptions over there, because here we do not give any color of the salt like black, like deep blue, etc. But there are some salts, those having this type of colors. Now we, after the determination of color, or after some information about the salt, we have to test that particular salt chemically by which you can confirm the presence of a particular metal cation in this particular salt. So first of all, we should discuss about how to determine the basic radical part present in a salt solution. Basic radical part, that is the positive part, that is the cationic part. Now we add some amount of sodium hydroxide solution, small one, that is sodium hydroxide solution in a metallic salt solution. So how we should execute? When sodium hydroxide solution is added drop by drop to a solution of metallic salt, this is a sample salt solution, the metal hydroxide form get precipitated. When you add some amount of sodium hydroxide, suppose a salt contains metal sulfate, and when you add sodium hydroxide, then you see that metal separated as its hydroxide. This is in the form of precipitate. Precipitate means this is insoluble part that is separated from the reaction mixture. Okay, so when some amount of sodium hydroxide solution is added drop by drop to the solution of metallic salt, that is actually given to you in order to determine the cationic part of the salt, that metal hydroxide form get precipitated. Now from the color of this metal hydroxide precipitate, you can confirm the presence of a particular metal ion. How this is possible? Now take some example. Here you see that, and the color of the precipitate identifies the metal ion. So different metal hydroxide having different color, different metal hydroxides having different color. If there is similar color in different metal hydroxide, then there is some other technique by which you can determine which one is actual metal ion present in the sample. Some precipitated, here you see, some precipitated metallic hydroxides dissolved in excess amount of sodium hydroxide to give soluble complexes. Here is another important point, that suppose let me clear this part, second part, that is, suppose you are given two salts like aluminium ion. Okay, you are given two solutions, two sample solutions like aluminium and magnesium. Okay, now you add some amount of sodium hydroxide solution in both of them. Here aluminium hydroxide precipitates aluminium hydroxide, here magnesium hydroxide precipitate. Okay, now aluminium hydroxide having color gelatinous white, and this is also gelatinous, or the precipitate is magnesium hydroxide, not aluminium hydroxide. So aluminium and magnesium both are colorless salt, and also both of them reacts with sodium hydroxide, produces aluminium hydroxide and magnesium hydroxide. So how you should confirm, without knowing anything, how you should confirm that your sample contains aluminium or magnesium? Next, what you have to do? Next, this precipitate again reacted with excess amount of sodium hydroxide. Now, if the precipitate is aluminium hydroxide, then sodium hydroxide reacts with aluminium hydroxide with the formation of sodium aluminate. This is soluble. But magnesium hydroxide, when reacts with excess, this is excess amount. Previously we have add some amount of sodium hydroxide, now we add excess amount. But here you see that no change in precipitate, that is unreactive towards sodium hydroxide. So this type of experiment by using excess sodium hydroxide, you can differentiate between aluminium ion and magnesium ion. Though magnesium and aluminium, they react with sodium hydroxide and produces similar precipitate, similar color precipitate of aluminium hydroxide and magnesium hydroxide, but this sodium hydroxide can be used to identify them by using some excess of sodium hydroxide. Aluminium hydroxide precipitate dissolves and the magnesium hydroxide precipitate present as it is. So it is a important part of this experiment that some of the precipitated metallic hydroxide dissolved in excess amount of sodium hydroxide to give soluble complexes, some other not. Some precipitate dissolves, some precipitates are not dissolved. So if you do not identify from the precipitate color or the color of the precipitate, then you should use this type of experiments. Is it clear to you? Can anyone say? Is it clear to you? How should
Yes, sir.
you should?
Yes, sir.
Yes, sir. Sir, I do have a question.
Okay.
Sir, if the means two different color means answer reacted, means sir copper and something else. Means copper is blue and something other means type of means which is of another color. Then sir, what color will it come? How can it come like that?
That is totally depends on mostly depends on the cationic part. That is the if color intensity, that depends. Actually copper when reacts with the other type of salts like copper, different samples of copper like copper chloride, it is green.
Yes, sir.
Copper sulfate, it is blue. Copper carbonate, it is green. So color generally arises mainly from the metallic part, where it is the non-metallic part that is also contains anionic part, also contains some of the metals. Like if you see that permanganate, this is permanganate, MnO4, it contains a metal, that's why it imparts some of the color. Like chromate, CrO4, it is negative radical, but it gives some color because of the presence of chromate. So if copper reacts with copper is generally blue in color, it reacts with chromate, CrO4. This is chromate generally yellow in color, but the copper chromate, they are generally brown in color. So color is not exactly the combination of cations and anions. They may impart different types of color because of the fact that color generally originates from the electronic transition. So when a compound forms, here its electronic configuration has been changed. So the different electronic configuration, different electronic transition, and gives the different color. This is a different type of chemistry that is not related to this particular chapter. We can discuss in another day, but generally the color is the cationic characteristics. If the anionic part do not have any metal ion, like sulfate is not do not contains any metal ion, so copper sulfate will be a blue. Copper chloride, that is generally blue green, etc. But if copper when attached with permanganate, then it changes its color. Okay, is it clear to you?
Yes, sir. Thank you.
Now the action of sodium hydroxide in subtle metal, what type of precipitate or what is the color of the precipitate, that is we should discuss. Initially, one important thing to consider that sodium hydroxide, in most of the cases we use sodium hydroxide as a reagent, but the potassium hydroxide can also be used in place of sodium hydroxide, and it also shows similar behavior. I mentioned this particular fact over here only because the fact that we mentioned sodium hydroxide added, etc. But in exam you get the reaction with potassium hydroxide, then they behave similarly. So there is not much difference between the using of sodium hydroxide or potassium hydroxide. We only use sodium hydroxide in the laboratory only because of the fact that sodium hydroxide is much more cheaper with respect to the potassium hydroxide. Potassium hydroxide is much more costly. That's why we generally use sodium hydroxide as a reagent. But the reaction and also the color of the precipitate and the etc. and the rate of the reaction also, they are such similar things that is obtained from sodium hydroxide. In case of potassium hydroxide, we get the similar, exactly similar observation that with sodium hydroxide. Now first we consider that when any calcium salt reacts with sodium hydroxide or potassium hydroxide, so calcium salt converted into calcium hydroxide. This is a white precipitate, white precipitate, white precipitate, and that is separated in this way. This, so you see this particular test tube where you see the precipitation of calcium hydroxide, and calcium hydroxide is such a precipitate that is insoluble when you add excess sodium hydroxide. Here if you add some excess sodium hydroxide, this is insoluble and no change in precipitate. So calcium can be identified from this particular experiment where you see that calcium nitrate or calcium chloride or calcium whatever may be the salt that reacts with sodium hydroxide, the formation of calcium hydroxide white precipitate. Now move on to next one, that is the ferrous sulfate or the ferrous ion. Ferrous ion, if a sample contains ferrous ion, then you add some few drops of sodium hydroxide to ferrous ion, you get a dirty green precipitate, this type of precipitate, ferrous hydroxide. So from this color, this is a unique color. It is only obtained in case of ferrous salts, and this dirty green precipitate it forms, and when you add some excess of sodium hydroxide to it, there will be no change in color, no change in color of ferrous hydroxide. So this is the identification of ferrous ion. When you get this type of observation, then you should confirm that your sample contains ferrous ion. Now move on to next one, that is the ferric salt. When sodium hydroxide is added into ferric salt, then you get a reddish brown precipitate. Here all the precipitate shown over here in the test tube, that you see that ferric hydroxide is reddish brown color, and that precipitate forms quickly with sodium hydroxide, and when excess of sodium hydroxide is added to it, then no change in precipitate. So precipitate will be present as it is. So this is the identification test of ferric salt, ferric ions present in the salt. You get, in this case, you get reddish brown precipitate of ferric hydroxide. Now move on to next one, that is a copper salt. It is most easiest of the all salts. That copper ions generally they are blue in color, but some of the salts like copper carbonate, that is green, and copper nitrate, it is also green, but most of the other salts are blue in color. So here you see that sodium hydroxide, small amount of sodium hydroxide is added into copper sulfate solution, then you get a pale blue precipitate of copper hydroxide, which is insoluble in excess of sodium hydroxide when added to it. When excess of sodium hydroxide is added to it, then no change. So this is another the confirmatory test of copper ions. All the reaction, all the balanced equation of each and every metal cation should be remembered, because these reactions are very, very important. All the questions in this chapter, depending upon those reactions, and those reaction balanced equation should always be remembered. Okay, now move on to next one, that is the zinc salt. When zinc salt reacts with sodium hydroxide, then it is converted into white gelatinous precipitate. Now white gelatinous precipitate is such a precipitate that so many different salts they give this type of precipitate. Like aluminium also give white gelatinous precipitate, magnesium also gives white gelatinous precipitate. So most of the salts they uh, colorless salts, they on reaction with sodium hydroxide produces white gelatinous precipitate. But the characteristics of zinc hydroxide is when you add excess of sodium hydroxide, then this precipitate is soluble with the formation of Na2ZnO2. This is known as sodium zincate. Sodium zincate. So zinc hydroxide, zinc hydroxide, zinc hydroxide when reacts with excess amount of sodium hydroxide, it produces sodium zincate, which is soluble. So if you add excess amount of sodium hydroxide, then uh, you shouldn't get any white gelatinous precipitate, but small amount of sodium hydroxide gives some precipitate, white gelatinous precipitate of zinc hydroxide. So this is, here you see that when you add excess amount of sodium hydroxide, then Na2ZnO2, this is a sodium zincate, is colorless and water soluble. So excess amount of sodium hydroxide, in excess amount of sodium hydroxide, zinc hydroxide is soluble. Now move on to next one, that is a lead. Lead salts reacts with sodium hydroxide with the formation of lead hydroxide. It is a uh, white precipitate. This is not gelatinous white precipitate. This is clearly white precipitate, milk-like precipitate. And this precipitate is readily soluble. This precipitate, lead hydroxide, is readily soluble in excess acetic acid, or even if you add excess sodium hydroxide, this precipitate is also soluble. So these observations are very much important. Which one is soluble in excess one, which one is soluble, which is not soluble in excess reagent. This is important for the identification of different cations. Now, white precipitate of sodium hydroxide. Here you see that white precipitate of sodium hydroxide, white precipitate of lead hydroxide formed by the addition of sodium hydroxide. And when you add excess amount of sodium hydroxide, then sodium lead tetrahydroxide, this compound form. This is colorless, and water soluble. So formula of this type of complexes are very much important. Now move on to another one, that is the ammonium salt. Though ammonium is not the metal, but ammonium salts are metal-like cation. They are positive, they are basic radical. So when sodium hydroxide or any other water soluble base is heated with ammonium salt, ammonia gas is liberated. So when ammonium hydroxide or ammonium chloride or ammonium salt, any ammonium salt, ammonium sulfate, like ammonium sulfate, it heated with sodium hydroxide, it produces no precipitate is formed in this case. It produces simply ammonia gas. So ammonia gas is a pungent smelling gas, and from this gas, the smell of this gas, you can identify the ammonia gas and ammonium radical also. So sodium hydroxide can be used to determine this type of cations. Now after sodium hydroxide, you can use ammonium hydroxide on certain salt. Now we should discuss by the use of ammonium hydroxide, because in some cases ammonium hydroxide give the different result. Here you see some of the cases. Now we add required amount of, or a small amount, initially small amount of ammonium hydroxide dropwise, exactly similar way what we have did in case of sodium hydroxide. So here you see that ammonium hydroxide when added to metallic salt, they also precipitate as metallic hydroxide, something like when we add sodium hydroxide and identified by their distinct color. So initially we add some sodium hydroxide to metal salt solutions and we get some observations, and now we add ammonium hydroxide to metal salt solution to get some observation by which you can identify the metallic portion, or you can say that a positive part, that is the basic radical portion of a salt. Now, some precipitated metallic hydroxide, they are also soluble in excess ammonium hydroxide, exactly similar that of sodium hydroxide. When sodium hydroxide, in some cases like aluminium, like zinc, like lead, where you add some excess amount of sodium hydroxide and the precipitate is dissolved, exactly in the similar way, ammonium hydroxide, when added in excess, uh, some of the compounds, they are soluble. They are those precipitates are soluble by the addition of excess amount of ammonium hydroxide. Now let's see what happens when ammonium hydroxide is added to metallic salt solution. Now, first of all, calcium salts. In case of calcium salts, ammonium hydroxide is a weak base and no precipitation of calcium hydroxide occurs even with addition of excess amount of ammonium hydroxide. Previously, you see that ions, calcium ions, calcium ion produces white precipitate when sodium hydroxide is added to it. But here you see that when ammonium hydroxide is added, there you get no precipitate of calcium hydroxide, because the concentration of hydroxide ions from the ionization of ammonium hydroxide is very low. Now, the problem is that ammonium hydroxide is a very weak base, and it dissociates partially to give OH minus, and this OH minus is very small concentration. Now that concentration is not sufficient to precipitate calcium as calcium hydroxide. So that's why it cannot precipitate the hydroxide of calcium. So this is another important information, that calcium forms calcium hydroxide. Calcium gives white precipitate of calcium hydroxide, when sodium hydroxide is added. But when you add ammonium hydroxide, then you do not get any sort of precipitate, because ammonium hydroxide is very weak base and ammonium hydroxide do not give sufficient amount of OH minus so as to precipitate calcium hydroxide. Now move on to next one, that is iron. Iron, that is ferrous ion and ferric ion. Ferrous ion and ferric ion, they behave similarly, exactly same way when we add sodium hydroxide. Like in case of ferrous hydroxide, we get white gelatinous precipitate, and in case of ferric, we get reddish brown precipitate. In this case also we get the similar observation. Just see, ferrous ion, when reacts with sodium ammonium hydroxide, it produces dirty green precipitate. This is dirty green precipitate with ammonium hydroxide, which is if you add excess amount of ammonium hydroxide, then no change in the precipitate. And when ferric, here you see some changes of ferrous hydroxide, initially some black appearance, and that intensifies, and ultimately you get this type of color, that is actually dirty green color. Here you see that when ferric ion reacts with ammonium hydroxide, it produces a reddish brown precipitate of ferric hydroxide. This is reddish brown precipitate of ferric hydroxide. Already we mentioned in case of sodium hydroxide, the exactly similar precipitate is obtained when we add sodium hydroxide. And ferric hydroxide is also insoluble in excess amount of ammonium hydroxide. Now this is most important, that copper ions, copper 2 plus, it reacts with ammonium hydroxide, produces pale blue precipitate of copper hydroxide. This observation is exactly similar to that of sodium hydroxide. But the second observation is totally different when we add excess amount of ammonium hydroxide to copper hydroxide. When you add excess amount of ammonium hydroxide to copper hydroxide, this precipitate is soluble and the color of the precipitate will be deep blue. Color of the precipitate is not pale blue. Color of the precipitate will be soluble and the solution having color deep blue. Like this is initially copper hydroxide form. This is copper hydroxide form, and after the addition of excess amount of ammonium hydroxide, this is small amount of ammonium hydroxide. This is this test tube left hand side, small amount of ammonium hydroxide, and when you add excess amount, this is excess amount, this is excess. When you add excess amount of solution, then cuproammonium sulfate, this compound forms with the deep blue solution. So the precipitate with excess ammonium hydroxide precipitate is dissolved. This is the confirmatory test of copper. If any sample contains copper, then this test will be used as the confirmatory test because no other cation responded in this way. Here you see that a small amount of ammonium hydroxide gives the pale blue precipitate, but if you add some excess amount of ammonium hydroxide, then you get cuproammonium sulfate, that is the deep blue solution. So this is the confirmatory test of copper ions in solution. Now next move on to zinc ion. Here you see that zinc ion, already we have mentioned that in case of sodium hydroxide, you see that white gelatinous precipitate is on. Here also white gelatinous precipitate is obtained when ammonium hydroxide is added to zinc ion solution. But another important observation here, that is the zinc hydroxide, when excess amount of ammonium hydroxide is used, then the precipitate with excess amount of ammonium hydroxide precipitate dissolves. The precipitate of zinc dissolves in case by the addition of excess amount of ammonium hydroxide, and the formula of the soluble complex is like this. So it is an important information that zinc hydroxide is soluble in excess of ammonium hydroxide. Here you see white gelatinous precipitate, but precipitate dissolves in excess amount of ammonium hydroxide. Now next one, that is the lead nitrate. Lead nitrate also behaves similarly that with sodium hydroxide. Ammonium hydroxide reacts with ammonium hydroxide from chalky white precipitate. This is the identification, very beautiful color, chalky white. This is actually the chalk like white, slight yellowish tint, but the color should be identified very easily. So lead, presence of lead in any sample is very easily identified by the addition of ammonium hydroxide, chalky white precipitate. So these are some important informations by which you can identify metal cations by the use of sodium hydroxide or potassium hydroxide. And here you see that some of the ammonium hydroxide, some metal cation reacts with ammonium hydroxide to produce some characteristic color of the precipitate, and by which you can identify the metal cations which are present in the sample. Now here some of the alkalis, they can react with metals, like those metals having amphoteric characteristics. Metals like zinc, like aluminium, like lead, they react with hot concentrated alkali to give corresponding soluble salt and liberate hydrogen. So this type of metals like zinc, aluminium, lead, etc., they react with acid to form salt and water, and they also react with base or alkali to form salt and water. That's why they having some exceptional character. That is, they react with both acids and bases with the formation of salt and hydrogen. So when zinc is reacted with sodium hydroxide, it produces hydrogen and sodium zincate. Or even potassium hydroxide, it reacts with potassium hydroxide to produce hydrogen. But here you see aluminium. Aluminium also reacts with sodium hydroxide uh, to produce hydrogen. Sodium aluminate and hydrogen also reacts with potassium hydroxide. All the balanced equation is very important. All the balanced equation is very important. Action of alkali on the zinc metal. Here lead also reacts in this similar way, where you see that sodium hydroxide reacts with lead with the formation of hydrogen gas. So these metals like zinc, aluminium, like lead, etc., they easily reacts with metals with the formation of hydrogen gas. Again, some alkalis, they react with metal oxides. Like metal oxide means most of metal oxides are the basic in nature. They react with like sodium oxide. They, when dissolved in water, produces sodium hydroxide. So this sodium hydroxide is soluble in water and form alkali. Sodium oxide, sodium oxide, this is metal oxide. Metal oxide reacts with HCl, salt and water. On the hydroxide, they react with HCl, salt and water, because sodium oxide and sodium hydroxide both are basic character. Metal oxides and hydroxides are basic in character. Amphoteric oxide, we have already mentioned that those oxides having both acidic and as well as basic characteristics. Like there are several this type of oxides like aluminium oxide, like zinc oxide, like tin dioxide, like lead monoxide, etc. Those having both acidic and basic character. So amphoteric oxides and hydroxide, those compounds which react with both acids and alkali to form salt and water. Suppose, for example, when you see the aluminium hydroxide, this is hydroxide, it reacts with sodium hydroxide, produces sodium aluminate NaAlO2 plus water. Now again, aluminium hydroxide reacts with HCl to produce aluminium chloride and water. So aluminium hydroxide reacts with sodium hydroxide. Sodium hydroxide is a base and it acts as acid. But when it reacts with acid, then aluminium hydroxide acts as a base. So aluminium hydroxide acts as both acid and base. That's why it is called as amphoteric. Here also see zinc hydroxide. It reacts with potassium hydroxide or sodium hydroxide with salt and water. And it also reacts with HCl to form salt and water. Here you see aluminium oxide forms salt and water also reacts with HCl to form salt and water. Lead monoxide also reacts with sodium. This is also amphoteric, reacts with sodium hydroxide to form salt and water. Here you see that lead monoxide reacts with potassium hydroxide to form salt and water. So these are the amphoteric characteristics, not as such identification, but in this chapter, this is discussed. That's why we mentioned this type of reactions where the amphoteric oxides and hydroxide, they react with acids or bases to produce salt and water, etc. Now this is all about this chapter. Now the one important homework for those students which participate in this class, that homework is you have to identify the name of number one, yellow monoxide that dissolves in hot and concentrate caustic alkali. What is the name of this yellow monoxide? And second one, that is white insoluble oxide that dissolves when fused with caustic soda or caustic potash. So in the next class, we discuss the name of these two compounds. Now, this is all about this particular chapter. গুড নাইট সবাইকে। আর আমরা এখানে ক্লাসটা শেষ করলাম। তো আমাদের অ্যানালিটিক্যাল কেমিস্ট্রি উই অলরেডি কমপ্লিট দিস অ্যানালিটিক্যাল কেমিস্ট্রি। I give some question answer of this particular chapter in the group where you can get some idea what type of questions should be asked from this particular chapter. Okay, thank you সবাইকে। গুড নাইট, টাটা।
Good night and thank you, sir. Bye.
Tata, sir.